Go through one more question, and just going to check my notes just to make sure I've got this correct. Okay, cool. Last question here. The first, this is question 4. And so here, part A, you want to draw x squared and x minus 2 all squared on the same number plane. Okay? Now we've quickly gone through what happens when you draw these particular graphs last term. I'm going to quickly draw them here. So I've got y, x. Now for y is equal to x squared, I'm going to draw this in red. And so it has a vertex at 0, 0. This is just your basic parabola. Looks something like that. So that's just for y is equal to x squared. Now the second one is y is equal to x minus 2 all squared. Now when you draw this graph, what happens is it moves to the right 2 units. So at 2, that's where the vertex goes. And so it just becomes something that looks like this. Okay. Now I drew that a little bit terribly, but bear with me. Okay, so I've drawn the 2 on the number plane. You can probably find, I think the y-intercept for this is 4. You can go check that yourself. Now, that's part A. Part B is you want to find the number of points of intersection. All we do is just we look at the graph and go, okay, when does these two graphs touch? Well, if you have a look, so each of these ends are going to keep going and they're never going to touch each other. And same over here and here. The reason for that is because the coefficient of the x term is actually the same. That's just a lovely fact. And so we only have this point in the yellow, so there's only one point of intersection. Now part C is you want to find any point of intersection using the graph or algebraically. Now if I drew these two graphs a little bit more accurately, you could probably tell where this point of intersection is. And if you drew it really like accurately and with the same scale, what you'll notice is that the x coordinate of this point here is actually 1. And you can figure out, you can substitute 1 into either one of the graphs and you'll find the y coordinate. However, you can also solve this algebraically. So I'm going to solve it algebraically. I've got y is equal to x squared and y is equal to x minus 2 squared, 1 and 2. I'm going to equate the two equations to solve them algebraically. So I've got x squared is equal to x minus 2 all squared. Now here what I'm going to actually do is I'm going to expand out the right hand side. So I've got x squared minus 4x plus 4. And then I'm going to solve it this way. Now I'm going to move everything to one side. I'm going to actually notice that actually, instead of moving everything to one side, I'm going to notice if I move my x squared terms all to one side, they're going to cancel each other out. I've got an x squared on the left-hand side, I've got an x squared on the right-hand side. I can subtract x squared from both sides and it'll cancel out. And so here, what I'm actually solving for is negative 4x plus 4 is equal to 0. And so what I'm going to do is I'm going to move this to the other side. Negative 4x is equal to 4. X is, oh, actually, that's not negative 4x. It just becomes 4x is equal to 4. And so x is equal to 1. And then I'm going to sub that value back into my equation. So sub x is equal to 1 into y is equal to x squared, for example, the equation number 1. And so y is equal to 1. And so my point of intersection is just going to be 1, 1, which is my x value and my y value here and here. So for this last question, I just went through it a little bit quickly, but hopefully it made sense. Yeah, points of intersection, the point of it, so you're drawing, if I draw the two graphs on the Cartesian plane, you'll notice that there's one point of intersection. And then when I'm trying to find the points of intersection, I can do that algebraically by solving the two equations, using simultaneous equations. Hopefully that was helpful. If you have any further questions, feel free to ask them. I'm more than happy to try and answer your questions as best I can. But yeah, have a go at a few of the questions in the chapter on finding points of intersection, and I'll see you hopefully tomorrow.